Warm up for lesson 8-1. Pause, and here are the answers. Lesson 8-1, multiplying and dividing rational expressions. Objective, to simplify rational expressions, simplify complex fractions. Let's go ahead and review the word rational. Rational is a ratio of two expressions, and we're going to be looking at the ratio of some polynomial expressions. Let's go back to elementary fractions, 8/12, and we can reduce it by dividing the numerator and denominator by the greatest common factor, and we get 2/3. Well, with algebraic fractions, we can do the same thing. We can factor the numerator, factor the denominator, and then divide both numerator and denominator by the greatest common factor, and this is the simplified fraction. Let's go ahead and look at an example, and you can see the greatest common factor will be the y plus 7, which we will divide the numerator and denominator by, and then what we have left is our simplified form. Under what conditions is this expression undefined? Well, anytime the denominator, the original denominator, is equal to 0, that's going to add some conditions. And in this case, this is the original denominator where this portion has been factored. And the answer is the values that would make the denominator equal to 0 are when we set each of these factors equal to 0. So it's undefined at y equal to -7, 3, and -3. All right, let's go ahead and continue to practice. We want to do two things. We want to simplify, and we also want to know the conditions under which the expression is undefined. So at first I'm going to factor the denominator. And when I see this, I can see that I can do some reducing, and then with this factor as well. So my answer is going to be 4 multiplied by the factor y plus 4 all over y plus 2. And in this case, under what conditions is the expression undefined? Undefined at, we go to the original denominator, y equal to 0, y equal to 3, and y equal to -2. There were 3 factors, so there's going to be 3 values at which it's undefined. Let's do this again. I am going to factor the numerator, and so this will be z plus 4 and z minus 2. And I'm going to go ahead and reduce. And what I have left is 2z, z plus 4, all over z minus 1. It's undefined, and again, you look at the original denominator, and so that'll be at z equal to 1, -5, and +2. Your turn. Your turn. Let's take a look at simplifying using -1. In this case, our greatest common factor in the numerator was a to the 4th power. a to the 4th, a to the 4th, showing up in both of them. So we factor that out and we get a b minus 2. And in here, we're going to take out the greatest common factor, which is a to the 3rd, and we'll get this one. Notice that these two almost look the same. If we were to factor out a -1 from the numerator, then we would get this expression right here. And we can check our work by multiplying. Negative times negative makes positive. Negative times positive makes negative. So we know that these two are the same. And so these two can be reduced, and they're going to leave a -1 behind. So the answer will be negative, and then we have this factor also that has not been reduced, a. Okay, let me go ahead and do the problem here. And so I see my greatest common factor in my numerator is z, so I'm going to do x minus 4. And then in the denominator I have z squared, and I have 4 minus x. Now these two almost look the same. If I can factor out a -1 from either the numerator or denominator, they would look the same. So instead of me doing all that factoring, all I'm going to do is 1 and then -1. In other words, when they reduce, we're going to have a -1. And remember, one of these z's is going to cancel out with one of these z's. So we have a z left behind. And so the answer is -1 over z. I just decided to put the negative in the front, and of course the z in the denominator. Let me do this again. I see my greatest common factor is AB, and then I'm left with b minus 5. And there's nothing to do in the denominator. But I do notice that these two are very much the same, and if I were to factor out a -1, they would reduce with a -1 left. And so this answer is negative a times b all over 5 plus b. Pause to do the problem, and here's the answer. Let's take a look at reviewing multiplying rational expressions, or multiplying fractions and dividing with fractions. Okay, so here's our elementary example. 3/5 times 2/7. Notice there's no reducing. All I do is multiply across 6, multiply across 35. In a division problem, remember you change it to multiplying by the reciprocal, and there's nothing in common to reduce, so it's multiply across 21, multiply across. Now division could also look like this. It could look like a complex fraction, and remember this is just the same thing as 3/5 divided by the denominator, and I'm back to this problem again, which the answer we know is 21 over 10. All right, let's take a look at an example here. We have this multiplication problem, and the author demonstrates us breaking it down. Now you don't have to do this. You can just do this. 8 goes in here 1 time, 8 goes in here 2, 7 goes in here 1, 7 goes in here 3. So you know you're going to get the 6 down here. And you have 1x here and 3 x's in the denominator, so you know you're going to have 2 x's. And you have 2 y's in the numerator, 3 y's here, so you're going to have a y. So if you can go from here to here, that's okay. Let's take a look at dividing. So dividing, we're going to change dividing by multiplying by the reciprocal. And once you get this, again, you can go through all of this, or you can take a shortcut and just start reducing here. And I know I'm going to get a 4 in my numerator, and I know I have more k's in the numerator, and I'm looking at my d's. I have 2 here and 1 here, so I know I'm going to have 1, and I have 5 m's down here and 1 m here, so I can do m to the 4th. So you don't have to go through all this process, but if that helps you, go ahead and do that. Let me go ahead and do this problem from scratch, and I can see that 7 goes in here 3 times, 7 goes in here 2. I can see 4 goes in here 2 times, and 4 goes in here 3. Now I have a 2 and a 2, and a 3 and a 3, so I can do one more time, go through some reducing. So I know that I won't have any numbers here. And now what I'm going to do is take a look at my A, B, C, and D. So in my A's, I have an A squared here and an A here, so I know I'm going to have 1 A in the numerator. I have a B in the numerator and a B in the denominator, so I won't have any more B's. As far as C's, I have 3 C's in the numerator and 2 C's here, so I know I'm going to have 1 C here. 2 D's in the numerator, 2 D's in the denominator, so that's D. And it looks like I don't need that. It looks like I don't need that division symbol here because this is A, C, D. That's my simplified form. All right, here I'm going to change it to multiplying by the reciprocal. So this is going to be 7a squared b squared all over 24 m to the 3rd. Okay, 7 goes in here 1 time, 7 goes in here 3, 8 goes in here 2 times, 8 goes in here 3 times. And now I'm ready to start writing my answer. I'm going to have a 2 in the numerator and a 9 in the denominator. As far as my m's are concerned, I have more m's in the denominator. As far as my t's are concerned, I only have t squared. My a's, I have more a's in the denominator, that's a squared. And my b's, I have more b's in the denominator, that's going to be a b down here. And so there's my answer. Okay, pause and see what you can do on those two problems. And here are the answers. Pause, practice one more time. And here's the answer. Pause, and here's the answer. Let's take a look at more complex multiplication and division problems with polynomials and not just monomials. Okay, in this case, I want to factor this, and so that's what this becomes. And I do also want to factor this part, and that's what this becomes. Once everything is factored, then we can go ahead and start reducing. And it looks like this term and this term right here are going to be reduced, and it's going to be reduced to -1. So there's going to be a -1 behind. And so the answer is -1. Let's take a look at a division problem. Remember, division is multiplying by the reciprocal. And I'm going to get my greatest common factor, which is 2, out. You can see it here. And I'm going to factor this, and I have it right there. Factor this, I have it right there. Once we do that, we can see some reducing going on. And what's left, that's what's going to be the numerator. What's left here, that's what's going to be the denominator. Okay, let's go ahead and practice. Let me go ahead, and it looks like the greatest common factor is 4. 4 times x minus 5. And then this will be x plus 7, x minus 5, and then this will be x minus 5 and x minus 2, and then I have a 4. If I factor out a 4, I'm going to get x squared minus 4, and I can see this can still be factored. So this is x plus 2, x minus 2. All right, now I'm going to do some reducing, and I can do it here, and I can do a 4, and I think I'm done. Okay, so my numerator will be x minus 5, and my denominator is x plus 7 and x plus 2. Let's do it again over here. This is going to be x. Let's see, it's minus 4 and x minus 5 all over x plus 7, x plus 3. Now here I'm going to have to do it the reciprocal, so I'm going to put this in the numerator, so that's 6 times x plus 7, and when I factor this one, will be x minus 4, x plus 3. And now I'm ready to reduce. And that looks like all I can do. So now my numerator is 6, x minus 5, all over x plus 3. You can write it out twice or just write a little square like that. Pause. And here's the answer. Pause. And here's the answer. Let's take a look at simplifying complex fractions. This is really a division problem. So I can just take my numerator right here and put it here, and then divide it by my denominator. And now we're back to a division problem where I change it to multiplication, and then I do all my factoring, and then I end up getting this. Now, remember that these two will reduce to -1. They're off there. You can factor a -1 out. Okay, let me go ahead and do this problem. So this is going to be x minus 2 times x minus 2. I'm going to just write it out twice. 2 times x minus 4, x minus 1, divided by, and I'm not going to do any reciprocals yet. I'm just going to write what I see here. X plus 2, x minus 2, all over 2 times x. So that's 2 times 2x minus 5. All right, now I'm going to change division into multiplying by the reciprocal. And so now I'm going to have that in my numerator, and I'm going to have that in my denominator. Okay, let's go ahead and reduce. And one more here, and then we can reduce some 2's. And we have 2x minus 5 all over x minus 4 times x plus 2. Okay, pause to see if you can do the problem on the right. And here's the answer. Pause. And here's the answer.